The National Electrical Code, NEC, does not permit the application of demand factors or diversity when calculating the electrical load for instantaneous electric water heaters. This means that when determining the size of the electrical service, feeder, and branch circuit conductors, as well as the overcurrent protection for these types of water heaters, the full nameplate rating of the water heater must be used. The NEC mandates that electrical systems must be designed and installed to safely handle the maximum potential load. Demand factors and diversity are concepts that allow for a reduction in the calculated load based on the assumption that not all electrical equipment will be operating at its maximum rating simultaneously. However, due to the nature of instantaneous electric water heaters, which draw a significant amount of current for a short period whenever hot water is needed, the NEC does not allow for this reduction. To understand the implications, it is important to clarify a few key terms. An instantaneous electric water heater, also known as a tankless water heater, heats water directly without the use of a storage tank. When a hot water tap is turned on, cold water flows into the unit, and a high-powered electric heating element is activated to quickly raise the water temperature to the desired level. This process requires a substantial amount of electrical energy, often resulting in a high amperage draw. The nameplate rating of an electrical appliance is the maximum amount of current or power that the appliance is designed to draw under normal operating conditions. This rating is typically marked on a label affixed to the appliance and is expressed in amps or watts. Electrical service refers to the main electrical supply to a building or facility. The service must be sized to accommodate the total calculated load of all electrical equipment within the building, with additional capacity for future expansion. Feeder conductors are the wires that carry electrical power from the service equipment to a sub-panel or distribution panel. These conductors must be sized to handle the total load served by the panel, taking into account any applicable demand factors or diversity. Branch circuit conductors are the wires that carry electrical power from a panel to individual electrical loads, such as lighting fixtures, receptacles, and appliances. These conductors must be sized to handle the load of the specific equipment they serve. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices must be sized to match the ampacity of the conductors they protect. The NEC provides detailed guidelines for calculating electrical loads and sizing conductors and overcurrent protection devices. These guidelines are intended to ensure the safety and reliability of electrical systems. For instantaneous electric water heaters, the NEC requires that the full nameplate rating be used in a load calculation. This means that no reduction is allowed for demand or diversity. The rationale behind this requirement is that instantaneous water heaters can draw their maximum current for extended periods, especially in households with high hot water usage. Therefore, the electrical system must be capable of handling this load without overheating or causing a voltage drop. Consider an example. Suppose an instantaneous electric water heater has a nameplate rating of 60 amps. According to the NEC, the branch circuit conductor serving this water heater must be sized to handle at least 60 amps. The overcurrent protection device must also be rated at 60 amps or the next standard size up, if 60 amps is not a standard size, in accordance with NEC section 240.4. Similarly, the feeder conductors supplying the panel that serves the water heater must be sized to include the full 60 amp load of the water heater without any reduction for demand or diversity. The electrical service to the building must also be sized to accommodate this load. Failure to properly size the electrical system for an instantaneous electric water heater can result in several problems. Firstly, the conductors could overheat, potentially leading to insulation damage and a fire hazard. Secondly, the voltage at the water heater could drop excessively, which can reduce its performance and lifespan. Thirdly, the circuit breaker could trip frequently, causing inconvenience and potentially damaging the water heater. It is important to note that the NEC is a comprehensive set of rules and regulations that cover all aspects of electrical installations. The code is updated every 3 years to reflect advancements in technology and changes in industry best practices. Therefore, it is essential to consult the latest edition of the NEC for specific requirements related to instantaneous electric water heaters. In addition to the NEC, local electrical codes and regulations may also apply. These codes may impose additional requirements or restrictions on the installation of instantaneous water heaters. It is always advisable to consult with a qualified electrician to ensure that the electrical system is properly designed and installed in accordance with all applicable codes and regulations. When selecting an instantaneous electric water heater, it is important to consider the hot water demand of the household. Instantaneous water heaters are available in various sizes, with different flow rates and temperature rise capabilities. A larger water heater will be able to provide a higher flow rate of hot water, but it will also draw more current. It is important to choose a water heater that is appropriately sized for the household's needs to avoid overstressing the electrical system. In summary, the NEC does not allow for demand diversity when calculating the electrical load for instantaneous electric water heaters. The full nameplate amperage must be used to determine the required size of the branch circuit conductors, feeder conductors, overcurrent protection devices, and electrical service. This requirement is intended to ensure the safety and reliability of electrical systems and to prevent overheating, voltage drop, and other potential problems. Always consult the latest edition of the NEC and local electrical codes for specific requirements, and consult with a qualified electrician to ensure that the electrical system is properly designed and installed. Furthermore, it is beneficial to understand the basic principles behind electrical load calculations. The process involves several steps. Firstly, identifying all the electrical loads that will be connected to the system. Secondly, determining the amperage or wattage of each load. Thirdly, applying any applicable demand factors or diversity. Fourthly, summing the loads to determine the total calculated load. Fifthly, sizing the conductors and overcurrent protection devices based on the calculated load. For most types of electrical loads, the NEC allows for the application of demand factors or diversity. These factors take into account the fact that not all loads will be operating at their maximum rating simultaneously. For example, lighting loads may be subject to a demand factor of 100% for the first 3000 volt amps, 35% for the next 120,000 volt amps, and 25% for the remainder. This reflects the fact that not all lights in a building are likely to be on at the same time. Similarly, receptacle loads may be subject to a demand factor based on the square footage of the building. The NEC provides tables and guidelines for determining appropriate demand factors for various types of loads. However, as previously mentioned, no demand factors or diversity are allowed for instantaneous electric water heaters. This is due to the high current draw and the potential for extended periods of operation at maximum load. When working with electrical systems, it is important to follow all safety precautions. Always disconnect the power before working on any electrical equipment. Use properly insulated tools and wear appropriate personal protective equipment. If you are not qualified to perform electrical work, consult with a licensed electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent injury or property damage. In addition to the NEC, there are other industry standards and best practices that may be relevant to the installation of instantaneous electric water heaters. These standards may cover topics such as water quality, venting, and grounding. It is advisable to consult with industry experts and manufacturers' recommendations to ensure that the installation is performed correctly. The NEC provides specific requirements for the wiring methods used to connect instantaneous electric water heaters. These requirements typically specify the type and size of conductors, as well as the type of conduit or cable that must be used. It is important to follow these requirements to ensure that the wiring is properly protected from physical damage and environmental factors. The NEC also addresses the grounding and bonding of electrical equipment. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow back to the source. Bonding is the process of connecting non-current carrying metal parts of electrical equipment together to create a low impedance path for fault current. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the proper operation of overcurrent protection devices. The NEC requires that instantaneous electric water heaters be grounded and bonded in accordance with specific requirements. These requirements may vary depending on the type of wiring system and the location of the water heater. It is important to follow these requirements carefully to ensure that the electrical system is safe and reliable. When installing an instantaneous electric water heater, it is important to consider the location of the unit. The water heater should be located in a well-ventilated area to prevent the buildup of moisture and condensation. It should also be located in an area that is easily accessible for maintenance and repairs. In some cases, it may be necessary to install a dedicated electrical panel for the water heater. This panel should be sized to accommodate the full load of the water heater, as well as any other electrical loads that will be served by the panel. The NEC provides guidelines for determining the appropriate size of electrical panels. When selecting a location for the water heater, it is also important to consider the proximity to hot water fixtures. The closer the water heater is to the fixtures, the less time it will take for hot water to reach the tap. This can save energy and reduce water waste. In addition to the electrical requirements, there may also be plumbing requirements for the installation of an instantaneous electric water heater. These requirements may cover topics such as water pressure, pipe sizing, and backflow prevention. It is important to consult with a qualified plumber to ensure that the plumbing system is properly designed and installed in accordance with all applicable codes and regulations. In conclusion, understanding the NEC requirements for instantaneous electric water heaters is crucial for ensuring the safety and reliability of electrical systems. The NEC mandate to use the full nameplate amperage for load calculations without applying demand factors underscores the importance of accurately assessing the electrical demands of these appliances. By adhering to the NEC guidelines, electrical professionals and homeowners alike can mitigate the risks associated with overloading circuits, preventing potential hazards such as overheating, voltage drops, and electrical fires. Moreover, compliance with the NEC ensures that the electrical infrastructure is robust enough to support the consistent and efficient operation of instantaneous water heaters, providing a reliable hot water supply while safeguarding the electrical system from undue stress. Remember to always consult the most current edition of the NEC and local electrical codes for the most up-to-date regulations and to seek guidance from qualified electricians and plumbers to guarantee that all installations meet the required safety and performance standards. This comprehensive approach not only protects property and lives but also contributes to the overall integrity and longevity of electrical and plumbing systems.